This is a follow-on investigation specifically of the DF robot heat sinks that I measured in a previous video where I found the effectiveness of those heat sinks was pretty marginal. So I decided I should take a closer look with some more accurate instruments and see if that actually is the case. And also later on, I did a test with easy cargo stick-on heat sinks to see how effective those are as well. And this is also to sort of justify in my mind going forward, what's a relatively inexpensive but also still effective heat sink. The device I'm going to be using to measure temperature is called an RTD, that's Resistance Thermal Detector. And as the temperature goes up, the resistance goes up, and it allows for a much finer measurement than the thermocouple. With the thermocouple, I could get plus or minus a degree Celsius. With the RTD, I can get plus or minus about 1/4 of a degree Celsius. If we're looking for a small change in temperature, it would be better to use the RTD. And RTDs come in different shapes and sizes and types. There's a number of different RTD types out there. This particular type comes on a chip which has some platinum traces on it, and other ones are surface mount RTDs. Those are available, and then there's other different kinds that are wound platinum wire and things like that, but that's beyond the scope of this experiment. And you can buy these for a few dollars off of the internet in either the either the chip form or the surface mount form. The past heatsink experiments that I tried, I used the CIA chips. I used one of them, and in this experiment, I'm going to use the Kernal ROM because I don't have any CIA chips left that don't have heat sinks attached to them that I can remove easily. So I'm going to use the Kernal ROM. It's the one there in the center. It's between, on the left, that's the basic, and that should be the character on the right. Also, it does heat up more than the CIA chip, so we'll get to see more of a temperature difference, and we'll get to gauge effectiveness of the heat sink a little bit better. Here's a simple model showing the Kernal ROM and how the RTD is positioned on the bottom of that chip. I use this C64 to test chips. It's my test unit, and I'm going to use this one for the experiment. And you can see here what I've done is I've put very large heat sinks on the VIC-2 and the PLA. The SID on this particular unit did not work when I got it, so there's just nothing there right now. Okay, so the results. If we look at the DF robot heatsink with Arctic MX4 like I used in the last experiment, we get a drop in temperature we get a drop in peak temperature of about 3.4 degrees Celsius relative to what there would be with no heat sink. If we attach the tape that comes with the DF robot heatsink to the bottom of the heatsink, and we use that instead of the MX4, we get a negative 2 degrees. That is a 2-degree drop relative to no heat sink. So there is actually a benefit to using this heat sink, even if it's not as much as some other heat sinks. If you have this and you have no other options, it's probably still worth using it. And then the other heat sinks, these are the ones I like. I bought a bunch of easy cargo heat sinks. Those seem to work really well. They have the adhesive tape, double-sided adhesive tape already stuck to the bottom of them. You just stick it right on the chip. I, in this case, just use one right over where the die is, where all the heat's going to be generated in that small area. And I got a improvement of almost 5 degrees Celsius cooling. So I would say if you have a choice between these two heat sinks, they're about the same price, about $1 a heat sink. If space is not an issue, And I don't think it will be if you're talking about a Commodore 64 or a Commodore VIC-20. Then I would definitely go with the Easy Cargo. That seems to work a lot better than the DF Robot. If you have something where space is an issue, like the inside of a ZX81 that is a Timex Sinclair 1000, maybe in that case the DF Robot heatsink is what you could use, and it looks like you'll still get some cooling benefit out of it. And you could probably increase that if you used a double-sided thermal tape. That is a double-sided tape that is specifically meant to conduct heat well. Here's a plot of temperature versus time for the different trial runs that I did, and you can see by about 60 minutes for these size of heat sinks, you get almost up to a steady state operating temperature. Going forward, when it comes to putting heat sinks on things in Commodore 64s or Commodore VIC-20s, I think I'm going to keep using these Easy Cargo ones. Inside the C64 and inside the VIC-20, there's plenty of room for these things, with the possible exception of if you, for some reason, wanted to keep the cover on the VIC-2 chip or the VIC chip. Then I'm not sure if the Easy Cargo heatsink would fit, but I usually leave those covers off to maximize cooling.